Hello and good day. Welcome back to our class. This is teacher Oni de Guzman and our topic for today is solving a right triangle given the length of hypotenuse and length of one leg. This is for grade 9, quarter 4. Solving a right triangle means finding the measure of its remaining parts. So trigonometric ratios for any given angle can be determined using scientific calculators. Also, this can be used to determine an angle given the value of its trigonometric ratio. Before we solve a right triangle, let's review first how to use the calculator. So let's have example number 1 here. So find the value of trigonometric ratio given the angle. For 8.1, find the value of cosine 48 degrees. So again, we will press cosine 48 equals sign and we will come up with 0.669,130,6064. After pressing your calculator, you will get cosine 48 is equal to 0.669, correct to 3 decimal places. Another example is find the value of tangent 25 degrees. Again, press tangent 25 degrees equals sign and we will come up with 0.466307658. Again, after pressing your calculator, you will get tangent 25 degrees is equal to 0.466, correct to 3 decimal places. Using an online application of desmos.com or slash scientific calculator, I simply use this trigonometric function. So I'll move on to main, and you can see here, we have here sine, cosine, tangent. So again, going back to example a while ago, I'll get the cosine 48 degrees. As you can see, if you press enter, you will come up with 0.669,130,6064. On the other hand, if I'll type in tangent 25 and enter, so we'll come up with 0.663076582. So let's move on to the next exercise. This time is finding an angle given the value of trigonometric ratio. So sine theta is equal to 0.57, find the theta. So in order to find the theta, so that is press second function, sine 0.0657, close parenthesis. By the way, this is optional in other scientific calculator. Press equal sign and you will come up with 41.07147508. Again, after pressing your calculator, you will get, we read this one as arc sine. That is sine raised to negative 1, read as arc sine. 0.657 is equal to 41.714 degrees, correct to 3 decimal places. Another example is tangent theta is equal to 0.23, find the theta. Again, press second function, tangent, the digit 0.423, close parenthesis, equal sign, and we will come up with 22.92836209. So again, after pressing your calculator, you will get arc tangent 0.423 is equal to 22.928 degrees, correct to 3 decimal places. Again, using the online application of desmos.com/scientific calculator. So this time, as you can see here, you have main ABC function. So we will press the function. Then we can see now here the arc sine, arc cosine, and arc tangent. So a while ago, we have, okay, sine theta is equal to 0.657. So what we're going to do is we will press arc sine 0.657, close parenthesis, then enter. As you can see, we have the value of 41.07147,508. Another example a while ago is tangent theta is equal to 0.423. So this time we will press now arc tangent and the value of 0.423, close parenthesis, then enter. As you can see here, we have the value of 22.92836.209. Let's move on to the third exercise. So that is converting decimal form to degrees, minutes, seconds form. So example here is convert 41.07147508 to degrees, minutes, seconds form. So what you're going to do in your scientific calculator is press second function, degrees or DMS, then the numbers 41.07147508 and press equal sign. So you will come out with 41 degrees, 4 minutes, and 17.31 seconds. On the other hand, if you would like to convert 0.669130664 to degrees, minutes, seconds form, again, press second function, DMS, then we will press the number 0.669130664. Then don't forget to put equal sign, and we will have now 0 degree, 40 minutes, and 8.87 seconds. Alright, in order to convert decimal degrees to degrees, minutes, seconds, so we will use another online application which is entitled rapidtables.com. So we have here, make sure this is in decimal degrees, then put in the numbers here. So the number here is actually 41.07147508. So this is in degrees. Then we will press convert. As you can see, the 41.07147508 is converted into degrees, 41 degrees, 4 minutes, and 17.31 seconds. Okay, so another example a while ago is this value of value of 0.6691306064. Then we will press convert. So we come up with 0 degree, 40 minutes, 8.87 seconds. So that is how we use the online application. Now that you know how to use the scientific calculator, let's solve now the triangle. So given the right triangle, triangle FBH, where angle B is a right angle, find angle F, angle H, and the H. So let's find the angle F. So given that B is equal to 17, so that is your hypotenuse. F is one leg. So we can use the trigonometric function of sine f is equal to opposite over hypotenuse, such that our opposite is equal to 15. So that is the opposite side. And the hypotenuse is equal to 17. But we are looking for the angle f, so that's why we will press, second function, sine, then 15 over 17, press equal sign, so we will come up with 61.92751306. Now, if we will convert this one into degree, minutes, and seconds, so press second function, DMS, 61.9275140306, and equal sign, so we come up with 61 degree, 55 minutes, and 39.05 seconds. So this is the value of angle F. And our next exercise is find angle H. So given that B is equal to 17, so that is the hypotenuse, and F is equal to the adjacent side of the angle H. So we will use the trigonometric function of cosine H. So that is adjacent all over hypotenuse. But we are looking for the adjacent, which is 15, and hypotenuse is equal to 17. So cosine H is equal to 15 over 17. But I want to find out the H. So that is why I'll use the scientific calculator such that I'll press second function cosine 15 over 17 equal sign, so I'll come up with 28.07248694. So again, if I want to convert this one into degree, minutes, and seconds, I have press second function DMS, then press 28.07248694 equal sign, so I'll come up with 28 minutes or 28 degrees, 4 minutes, and 20.95 seconds. There is an alternative way to find the angle H. So take note that angle F and angle H are complementary angles, then their sum is equal to 90 degrees. So we found out that angle F is equal to 61 degrees, 55 minutes, 39.05 seconds. So then angle H is equal to 90 degrees minus the value of angle F. But angle F is equal to 61 degrees, 55 minutes, 39.05 seconds. So we have here H is equal to the difference of these two numbers. So using our calculator, so press 90 minus 61 DMS, 55 DMS again, 39.05 DMS, and will come out with equal sign is equal to 28.07248611. Again, to convert this one into degree minutes seconds, so press second function DMS. We have 28.07248611 equal sign. Then we have 28 degrees 4 minutes 20.95 seconds. So this time, let's look for the value of h. So take note that we are looking for one of the legs. So b is the hypotenuse and f is the other leg. So we will use the Petergorn Theorem such that the square of the hypotenuse b is equal to the sum of the squares of the other legs. So that is b squared is equal to h squared plus f squared. However, I'm looking for h. Subtract both sides of the equation by f squared. So I'll come out with h squared is equal to b squared minus f squared. Since I'm looking for h, I'll extract both sides of the equation. Square root of both sides of the equation. So I'll come up with h is equal to square root of b squared minus f squared. However, b is equal to 17 squared minus f is equal to 15 squared. So performing the arithmetic, I have here 7 squared is equal to 289 minus 15 squared is equal to 225. So take the square root of 289 minus 225. So h is equal to square root of 64. So h is equal to 8 units. To summarize our discussion in solving a right triangle, given the length of hypotenuse and length of one leg means finding the measure of its remaining parts. Also in this lesson, we talk about or we use a calculator in finding the value of trigonometric ratio given the angle. Also find an angle given the value of the trigonometric ratio. And finally, converting decimal form to degrees, minutes, seconds form. So that ends our discussion on solving a right triangle. Again, this is Teacher Onid Guzman. Do not forget to subscribe to my channel so that you will be notified about my new videos. Thank you.